Hi everyone, my name is Aran Ashkenazi, and I'm the VP of Services and Field Operations at SentinelOne. Today in this demo, we're going to show a very unique and advanced type of attack, what we call a nation-state grade attack. Basically, that's a true fileless attack that will not utilize any files that are dropped on the system. The reason why we call these nation-state grade is because these type of attacks are also the type of attacks that will evade probably almost every security solution out there that looks at files or that uses any type of mathematical or any other type of static analysis to look into attacks. The actual attack itself is going to run first on an unprotected system, a Windows 7. We're of course running a slightly out-of-date Adobe system in order to utilize a vulnerability. So we're using Metasploit console to send a malformed PDF to the unsuspected host. That host is basically going to open that PDF inside a plugin within Internet Explorer. That particular PDF is set to basically weaponizing a vulnerability inside the Adobe plugin. It will create a buffer overflow and allow us to gain remote access to that machine. Once we do that, we're going to inject a password scraping tool called Mimikat, but without dropping it to the system, actually just injecting it to a remote process, and from that remote process, basically steal the admin credentials. Pretty scary, also a pretty complicated demo, not something that you'd see every day. After we'll do that first with the unprotected machine, we're going to run it again and do it with a machine that runs SentinelOne, showing you how SentinelOne endpoint protection can detect and deflect those memory attacks. So let's just, without further ado, let's just kick it off. So here we are. And for the first part, what we're going to do, we're going to open up our terminal and connect to our remote attacker machine. And let's just put our password in. And once we're in, we're going to execute the Metasploit console. Sorry, let's do that again. Well, security company after all, right? So here we are inside our console, and let's just start the Metasploit console. And after we run Metasploit console, what we're going to do, we're going to utilize a very specific exploit that is basically weaponizing a vulnerability inside an older version of Adobe Reader that sits inside the Internet Explorer, basically an Adobe plugin. So using the Adobe CoolType Sing exploit, it's a slightly malformed exploit, so not necessarily the one that comes out of the box. So if you try it at home, it might not work for you. Don't be surprised. Let's just run the exploit. And basically what it gives us is this URL, which we're going to serve for our unsuspected host. Now, most times this URL will arrive in some form of spear phishing email, social engineering, Facebook, Skype message, whatever. In other cases, it might just be that someone compromised a trusted website, like happened last year with Yahoo ad servers, and basically kind of planted in parts of the website, in some iframes or something, and you click it unknowingly that it takes you to a bad place, basically. So I'm basically serving it to Internet Explorer, and it runs. As it runs, it basically connects to that remote host, and if we go back, we're going to see on the server side, that is, we're going to see that there's a connection, and it sends a crafted PDF. This crafted PDF basically is that malformed PDF, and we can actually see that there's a PDF-like toolbar here that kind of runs. That's the Adobe plugin inside IE that tries to load that malformed PDF, but of course the PDF is weaponized, and basically what it does is it creates a buffer overflow inside the Adobe Reader, eventually gains access and kind of outside of the realm of Adobe and Internet Explorer into the system, injects itself to a couple of processes, and basically opens connections. If we go back here, we actually see that there's a couple of sessions open that says session 2 open, soon it will say session 3 open. It basically opens those sessions out to our target machine, and we're actually now compromising the machine. We're getting a foothold in that machine. Now, this particular exploit, the way that it works is that Internet Explorer will try to load the tab a few times, And after a while, 3 or 4 attempts, it will basically say, well, I give up. At that point, you'll get a very benign message, which doesn't say much, just say that, enter the flow was unable to run this particular page. And if you go back to the server, where things become a bit more interesting, we're going to do a list of all sessions, and we are basically in that machine. We have 4 sessions open to our target machine, and what we're going to do now is basically utilize one of those sessions, right? So I'm going to open up session number 4, and what I'm going to do with this session is actually use that scraping tool that I mentioned in the past, Mimikat. It's very common, very known type of tool, but this time I'm not going to drop it to the system. I'm actually going just to inject it to a remote process. So let's just do that. We're going to execute and put it into a remote process called taskhost.exe, and which is, seems very benign, very system-like, right? And the file that we're going to use is from directly called root, and it's called mimikat.exe. So what this will do actually, and I can actually show it to you here very, very quickly, it will run a new process, and basically that process will take the shape. We can actually close this browser window. It doesn't matter anymore. We're in the system. It's that scary. And let's just go here and look for show process from all users. Let me just go here and show you that we have one task host. And what we're going to do now is basically create another task host, but this time it's not really task host. It's more like Mimikat, right? And boom, we're in, actually. That's kind of the scary part. This is where we're in, we have foothold. There's actually 2 task host processes right now. So one of them is Mimikat. And when I got access to Mimikat, it also means that I can do, anything I want with the system. So I can basically scrape all the passwords. Now, normally when we do this live, this is the part when I kind of ask someone from the audience to come and, change the password or whatever. And what I thought that, we can do now is basically just pick any random, something from, let's see, what is it today? Let's go to Google. And so today it's St. Patrick's Day. So how about using the word Patrick? So let's just take. I'm just gonna copy, let's just take Patrick. Oh, apparently Patrick is also from Bob Sponge. I did not know that. So let's just take Patrick, and that would be our password. And what I'm going to do now, I'm going to change my password. So let's do change password. And we're going to go and change our admin password. The reason why I'm doing that is just, I want you to see that it's totally dynamic. I'm going to put my own password here, and then, since it's St. Patrick's Day, let's do Patrick. And save it. And what I'm going to do in the background, from an attacker standpoint, I am connected to the machine, and what we're going to do now is basically run this command that kind of prints a little bit more output to the screen, and then lastly, basically steal the password. So what we've done now, we run this command remotely on our target machine, and if I go all the way up, you will see, whoa. So my password, my admin password is actually Patrick, which we just changed together. And then I also have all the hashes of that admin password. I can actually now do whatever I want. I can nmap into this machine and basically, find my way in somehow. I can, move laterally within the organization. So this is really where we kind of utilize that vulnerability with an exploit to weaponize our way in via this attack. Now again, totally memory only, no files involved at all. So we saw the attack, scary stuff, but what we really want to see is how SentinelOne detects and prevents those types of attacks, which are again memory only. So let me just close down this sessions. And we're going to try the same thing, basically run the same thing over again. This time we're going to do it with our SentinelOne machine. So basically, you're going to take, this is the machine that we're going to use. Let's just, bring it closer, make it a bit busier. It runs SentinelOne. It has the same type of like Internet Explorer, Adobe. It's vulnerable to the same way, so it's not patched in any way. Before we run the exploit again, is quickly run to our management console. Let's just go to settings and verify that our policy is set to kill. Why? Because this time, in this particular demo, we want not just to show you detection, we actually want to show you deflection of the attack. Again, this memory-only attack. So again, I can resave my policy, go back to dashboard, and let's go at it. So again, we're in our attacker machine, running the Metasploit console. And as the Metasploit console runs, we're going to utilize the same attack, the same exploit. Run the exploit, run the server basically, and then serve that particular URL to our SentinelOne machine. In this particular case, we're not going to, so this is our machine. Let's do run, explore. So we're serving it to our machine the same way we've done earlier. We will see actually the sending crafted PDF message that appears here. So we will see that there is a remote connection to that machine, sending crafted PDF. Here it is. And now we wait basically for the exploit to run. And as it runs, boom, SentinelOne detects the attack. It deflects the attack as well. So we had a kill threat policy. It basically kills the browser. It kills any other processes that were involved in the matter of the attack. And then a message appears directly to the console of the user. It can also appear on the UI of the user. This is configurable. So it appears on the console, and we see that on a machine called S1 fileless. A few seconds ago, we have an attack. The file name is actually the URL. We'll see that in a minute. The policy is basically set to kill, so this particular threat was killed. Let's just go and have a deeper look into this particular threat. So, name of the threat, the file, which is actually the path. So if you look at the path itself, it says the URL that we used, and after the /, this is the actual resource that we actually try to load. The machine is called S1 fileless. IP workgroup, again, we can click the machine and see a lot of visibility into that endpoint, all the way through processes, network connections, etc. Nothing from cloud intelligence, because there is no cloud intelligence. There is no hash. There's nothing to sign. There's nothing to do any type of analysis. And this is where the strength of the SentinelOne solution comes to play. So it's seen on the network a couple of times, depending on the number of times that we actually ran it. And here we actually have our forensic report that starts with the endpoint network connection. So, we do see, let's just refresh this page for a minute. So we do see in the endpoint network connections, what we'll see is that the file, the sample, in this particular case, the exploit that ran, basically ran in memory, then connected to this remote website on actually two ports. First, it was port 8080, and then the connection to the server on port 4444. So we basically have that visibility also on the connections for any type of malicious attack. The attack overview shows us the high-level malicious categories of this particular attack. In this case, we have a lot of exploitation attempts. That's the majority of the attack here, and the deflection of the exploitation based on the anti-exploitation engine that is baked into the SentinelOne solution. And of course, some network activities, some other activities. We recorded a few dozens of events in this particular attack. If we go to the attack storyline itself, we actually see exactly the story of the attack as it unfolds. So here we have basically Internet Explorer that's being invoked via this particular URL. So we have the URL, we have all the events that are associated to that URL. All the file operations here are basically temporary files related to Internet Explorer. There is no actual dropper that goes to the system. This is actually interesting because utilizing such an exploit on top of Internet Explorer basically means that you can't even trust your whitelisting solution. because Internet Explorer is by far a very whitelisted application. What we're doing here as attackers, we utilize that white application, a vulnerability in that white application, to gain access to the system. So again, we can kind of go over and see everything related to file, process, any other type of operations. We can continue to kind of investigate it. Here we got the network connections as well. So really full-blown forensic report. And if we want to see it without a separation to the nodes, we can actually also take a look at the raw data report. Again, download it as CSV or JSON format, tap it into our API or syslog integration, and get it all into your other analytics solutions. So, in essence, what we've seen here in this particular demo is a true advanced attack, total fileless, that utilized a vulnerability in Internet Explorer. SentinelOne then detected the attack, and with the kill policy, basically also deflected the attack before we managed to do any damage.